Does anyone try 1A? No, A1. What do you have for A1?
4 sine squared theta over 5.
4 sine squared theta over 5. Okay, what about A2? For anyone?
A2 is the right.
It says find the possible values of R. U2 is U1 times R. Can you try this? Something like this.
No, but we already know that.
You already know that?
Yeah, because it'd be 20 times 4 sine squared.
So we can plus 2 times of that, and we don't have the third term, right? Yeah.
I mean, we could find it.
It's going to be useful, right? So let's see. R is U2 divided by U1. That is 16 sine squared theta over 3. That is 4 sine divided by 5. Theta is between 0 and 2 pi. And theta is not pi. Theta is not pi means theta is R is not 0. If theta is between 0 and 360, so what difference does that mean? Oh. Is there missing information? No, I already put it on.
Wait, is it the substitute?
What? You said something? Because the sum to infinity we end up being our 1 divided by a minus r, right?
Yeah, but we don't have like the values.
But we don't have to have the value. It should be in terms of that. So I don't know what an expression for r, yes, but the values. Wrong.
Infinite geometric sequences.
Yeah.
No?
For geometric sequences, infinite, you only need a and r. So I will have assumed that this r and a should do the justice. Let's see if that will work. Because I'm still looking at what is missing for this one. Oops, sorry. A over 1 minus r, right?
Yes.
A is 20. 1 minus that. So, what? You don't think we can? Why not?
Oh wait, no, wait, sorry.
So that becomes 100 here. So 100 divided by 5 minus 4 sine squared, right? But even that doesn't give us that. So we need something for r. Any clue? But if we simplify this as cos squared, wait, is that 3? Yeah, okay, let's see. 2 cos squared 2 theta in terms of sine is what? Maybe we are missing something, maybe we are not.
Do you have to use it?
Yeah, we can actually. So let's
Well,
see.
how?
What?
Well, oh yeah, but
4 sine squared 2 theta, right? So if we take 4 from here, that will be 5, that will be 1 plus 4 minus that. Okay, so 4 into bracket. If I need 2 here, I could take 3 plus 2 minus 4 sine squared theta. Can you see this? Guys, can you see this? This is 3 plus 2 bracket, 1 minus 2 sine squared, that. And this is your cos 2 theta. Okay? So we have that already. It's correct. But the second part is what I don't know. How what do they want us to do? Do you get my point?
Yes.
Let's see. Oh, we didn't capture that part. Mr. B. Oh. So, I hope it's not too far from the board. Yeah, hopefully. Does everybody get this? The last thing I tried to do here?
Yes.
Okay, let's do that again in a more neat form. Then we can look at the mark scheme and see what it meant by that second part. I don't understand that question. Because I feel we don't have enough information for that. Maybe I'm missing something, it's possible. I might have missed something. So the first one you have done, I think everybody did that quite well. Expression for R will simply be U2 divided by U1. If there was U3 and U3 also, then we can equate both of them. Then maybe, we can get something for R. So that's why I was a bit confused here. Okay, so it's 16 sine squared theta divided by 20, which is 4 sine squared theta divided by 5. So that's 1. So the possible values, which means we're supposed to get a number, I don't know. What? We need to find theta, but how do we find theta?
Can we find U3 and then use the geometric mean?
If we find U3, then you're just going back to what you did. Because to find U3, you're going to have to multiply that by that. Okay, let's see. Hold on, please. Let's take these ideas one by one. So U3 will have been 16 sine squared, right? Times 4 sine squared over 5. That will have been 64 sine to the power 4 theta divided by 5.
Can we use the geometric mean?
Okay, let's see. Geometric mean means that U2 squared is U1, U3, right? So let's see if that makes sense. U2 is what? 16, yeah? Sine squared theta all squared. U1, 20 times U3, 64 sine 4 theta. Because we actually formulated this from that, it's not going to make any difference, right? So this is sine 4, this is sine 4. 16 squared is the same as 4 times 64, I think. So that's 256. 16 squared is also 256. Sine 4 theta, sine 4 theta. Sine raised to the power 4 theta. So it doesn't really, because we actually formulated it from it. So it won't make any difference. So let's leave the second part. Yes, you were going to say something? Quickly, fast. We don't have time.
You can't do square root of 0.
You can just square root of 0.
Or no, root 0.
Root 0, yeah, root 0 is 0, it exists. Okay. So for the last part, which is that B part, we want to show that sum to infinity, right? So we know sum to infinity is simply A1 minus R, right? A is 20. 1 minus the R that we know. I don't know about this possible values thing. And even if you have possible values, so it means, oh, this is not, if you have possible values of R, then this is the one that could give us sum to infinity. Because here, can anybody tell me why? Yeah, because if indeed nothing is wrong with this question, maybe we are not thinking right yet. It means there are two possible values of R. So it's possible one of them gives the value of R where sum to infinity is not defined. What is that condition on R? For sum to infinity to be defined, what is the condition on R? R is less than or equal to 1. No, actually less than 1, not 1. R must be less than 1. Absolute value of R must be less than 1. It has to be a convergent sequence. Do you understand? If you have R greater than 1, it will be divergent. So, can somebody tell me why you think this meets that criteria?
Because 4 over 5 is a fraction.
Speak louder and fast, please.
4 over 5 is a fraction.
So, what about the sine square?
Sine cannot be. Theta cannot be more than 1.
That is it. Sine theta cannot be more than 1. So this is a fraction times a fraction is a fraction. So definitely this r is indeed less than or equal to 1. Less than 1 actually. We don't need equal to 1. Do you understand? Because even for the maximum value, which is 1, this is still 4 over 5.
Could you just say like r is less than 1?
No, it says find the possible values.
Yeah, so like
Is that, oh yeah, you have a point there. Well, maybe something, maybe that's what it meant, I don't know.
you just want a range.
Maybe it's a range, right? Maybe it's a range. This is definitely less than 1. So what we could have, just, you know, based on the new information we're discussing now, is that this, because I don't understand that question. Okay? Since, I could say that since sine theta, like that, less than or equal to 1 actually. Okay, for sine, not for the r. It implies that the square is also less than or equal to 1. Agree? So, which means our r, which is 4 over 5 sine squared theta, will be less than now, not less than or equal to, because this is 1 maximum, right? Okay, so less than 4 over 5 times 1. So r is indeed less than 4 over 5. Not less than or equal to. Okay? No. So less than or equal to, sorry. This is less than or equal to 1, so this is less than or equal to. So r is maximum of r, what we can get is 4 over 5. Maybe that's what they mean by the possible values of r. I would expect something like a range. You have a point. Somebody mentioned that. Who was that? Yeah. Maybe that's what it meant. Okay? Anyways, and that is the reason this can exist. Okay? Alright, but this is not r, this is not the exact value. This is a range, right? The exact value is this. So we can assume this is number 2. Hopefully, we'll check that soon. Okay? Then b. Where's that? Okay, we don't need that one. You see, this is why it's good to discuss solutions together. Ideas will come. So, S infinity, so I would say from S infinity is a 1 minus r. It implies that S infinity in this case is, what is k? 20. 1 minus r is 1 minus this fraction. 4 over 5 sine squared theta. So if we simplify that, 20, 5 minus 4 sine squared theta divided by 5. So this is the whole fraction. So that's like a number divided by a fraction. And we know what happens here. 100 goes to the top. Then you have 5 minus 4. Now the trick I used before we wrote this official solution, quote and unquote, is to look at the outcome. We know that there is something for sine squared. So if I'm not, you know, a teacher, I happen to be a student, what I'll try to do is to simplify this and try to see how I can reverse the answer. Am I making sense? So what do I mean by that? So look here. The bottom one is, because I already have 100 at the top, so I don't have a problem. So the bottom one is 3 plus that. So to be 3 plus, because I have sine, right? I change that to double angle for cosine in terms of sine, which we all know is 1 minus 2 sine squared. Hello, are you with me? So this is simply 3 plus 2. Oh, that's my 5, right? And this is the 4 sine squared, right? So what I'm going to do is, okay, I just break this into 2. Of course, you are not supposed to like simplify and say, oh, because left hand side is equal to right hand side. No, be smarter than that. So I'm just going to say 100. Then I say 3 plus 2 minus 4 sine squared. Then we factorize 3 plus 2 bracket 1 minus 2 sine squared. So I already know where I'm going. I'm just working towards it. Alright? Never bring this to this. Always take this one to that. So that will be 100. 3 plus 2 cos 2 theta. Using double angle for cos. Okay? This solution makes sense now because we have done some trig. Okay? Alright. let's see another interesting one. This one has to do with log, so let's see this one. Can you try this? It's medium level question.
Mr. Daniel.
Yes, quickly.
Can you check the masking for the
Oh yeah,
A?
that's true.
Are we right?
See that? We're actually right.
A.
Big brain. Because I was confused at first, what do they mean by value? So we asked, oh, we made one error. We didn't include the fact that R cannot be 0. And why is that important? There is a condition that theta is not this. Okay, when theta is pi, sine theta is 180. So because this has been disqualified, sort of, then it cannot happen. Even from this range here, sine of 0 is 0. Sine of 360 is also 0. Okay, so these two are out. So R can never be 0. So as a result, there's a need to include that. Okay, and do we have anything like minus? So this is not just, let's see, yeah, minus 1 can be there. So this is just the square directly instead of sine first. Okay, minus square directly. So less than or equal to 1. So we're going to say, I should add here, since 0 is less than theta less than 2 pi, then we can say 0 is less than sine squared theta less than or equal to 1. So let's add this one. Okay? So we removed the negative part. We also did something like, oh, it can never be 0 also, because of this condition. It's not a closed interval. If it's a closed interval, then it can take 0. And it can also take 2 pi. But it's an open interval. Alright? So 0 cannot be. We have to take that away. Okay? So I think that's the only thing. Okay. The greatest value. Actually, the greatest value can be done. It doesn't need calculus. I thought of this and I thought, okay, maybe we're going to need some calculus. So I explained that first. Now, listen to this. This is maximum because it's a fraction. Is it maximum? The greatest value. Find the value of theta for which this is greatest, for which this sum is greatest. Hello? Find the value of theta for which this sum is maximum. Okay? So we don't have to think of calculus here yet. A fraction is maximum when denominator is minimum. The smaller the number you divide with, okay, the bigger the number. Now, this is minimum when what happens? When cosine is -1. Because remember, cosine of any value is between -1 and 1. Right? And the least is -1. Do you understand that? So, by say find the values of theta, right? So, which means when cos 2 theta is -1, and that is the trig equation you will solve. So I think it's still part of something we can solve. And I'll show you that here now. Do you understand that? Again, the idea is, because I was thinking calculus initially, so that's why I wanted to skip it. But this has nothing to do with calculus actually. A fraction is the greatest when the denominator is the least. This denominator is least when this is the least. Remember, 3 plus something, right? The bigger this number, the bigger the sum, right? And the smaller this number, the smaller the sum. Okay? So when is this the smallest? When cos 2 theta, the cosine function, gives -1. So which means, if we are to find the value of theta to get the greater sum, you're actually finding the value of theta when cos 2 theta is equal to -1. Does that make sense? And cos 2 theta equals -1 is a trig equation that will be solved. Does that make sense? So that's one thing I skipped. So here it is. The greatest sum is this, 100, right? So which is, you don't have to put it, because we don't need the greatest sum. It's only said value of theta. So you can just explain. This fraction is maximum, again, when the denominator is minimum. The denominator is minimum when cos 2 theta is minimum. Cos 2 theta is minimum when it is equal to -1. And that is where you say cos 2 theta is equal to -1. Then you solve for theta. Do you understand that? So this is just trig equation. I take this and I write it properly for you.
I can pause.
What? No, don't pause. Wait. 100 divided by 3 plus 2 cos 2 theta is greatest when 3 plus 2 cos 2 theta is minimum. Okay? And this means when, so which means this is minimum when this cos 2 theta is minimum. Okay? Now, cos 2 theta is minimum, which implies when cos 2 theta is equal to -1. Why is that? The cosine of any x lies between -1 less than or equal to cosine of any angle x. I didn't use theta. Alright? I used x this time. Lies between that. So this is what we saw. So it means 2 theta equals the arc cos of -1. And that is how that was solved. Okay? Okay? So in the quadrant, we look at when do we have that. It's going to be on 180 and 180. Then because cosine is periodic at 2 pi, right? So the next one is 3 pi. Why are we extending to 3 pi? This is 2 theta. The range of values that we have is between 0 and this, right? So 2 theta will lie between 0 and 4 pi. Hello? So that's why it was extended to 3 pi. Okay? So these two can be used. So which means your theta is pi over 2, or your theta is what? 3 pi over 2. So this is the last part. Any questions? So reason here, since 0 less than pi less than 2 pi, then it means 0 less than, theta. 2 theta less than 4 pi. So that's why we're considering 2. Okay? Alright, so can we quickly look at this logarithm 1? Mr. Brandon, what's going on? You look lost.
So tired.
Come on, it's the last class for today. So let's look at this one. Five minutes, please. 5 minutes, quickly. Good picture. 5 minutes. Oh, okay. Question. 5 minutes, quickly. Send these guys the question first, so when they watch the video they can look at how we got it. Leo, you don't seem to be doing anything. 8 minutes. To save time, I'll just display the mark schema and add more information. Okay? Like this one, the way they explain it is not so detailed, so that's why I had to write it on the board like that 1C. Okay? Are you ready? Okay, what have you done? What did you get for common ratio? 2/3. So that the sum to infinity is in that. Are you able to do that? Yes, yes. Okay. The first 3 terms of an AP are this. Then you can think of arithmetic mean here, I believe. Because you have 3 terms, right? The first 3 terms are this. Find the common difference. What do you get for common difference? Minus? Minus 1. Everybody got minus 1? Larissa, Leo, you're not talking. I hear everyone to talk. What? You didn't finish. Okay. Now, S6 is the sum of the first 6 terms. So that S6 is this. Were you able to do this? Talk to me, people. Did you get S6 or you're still there? You're still working?
I got, yeah.
You got that? Okay. Given that S6 is 1/3 of the sum to infinity